Hello, this video tutorial will be for the purpose of demonstrating the butterfly valve assembly. To begin with, open up Inventor, select New, the Create New menu pops up, and we will verify that we are in the English template, and again we are doing an assembly, so we will use the standard .iam file, create. As we wait for Inventor to load, it is vital that you contain all your parts for the loan assembly in one single file, and that is a good practice for every assembly you create. It is just makes it a lot easier to locate the parts. We begin by selecting place, and we will place down the plate and also the shaft. When we do that, to select both of them, you must hold down the control key on the keyboard. Otherwise, you can only select one at a time. Go ahead and open those, and if you notice, it already placed down one, and it's asking me if I want to place a second set. Normally this is good for when you have multiple parts of the same. You can place down as many as you need. In this case we only need one of each, so it's already down. We right click, press OK. Notice that the shaft is demonstrating the sketch. You can see a sketch on the shaft. We don't want to see that, just for purposes to make the assembly a lot easier, as we have to orient the part a certain way, and the sketch may get in the way. In order to do that, we go to the log menu or the model menu, select shaft, open the pop down menu, and notice that there's a sketch here. We right click, and notice there's visibility is checked on. We simply check it off, and it's gone. Now, one last thing about grounding. Notice that the plate has a pin on the part logo. That means you cannot move that part. It is pinned to that location and it will not move at all. Notice the shaft, we click on it and we can drag it to where we want to place it, whatnot, not the plate. So to do that, you can do it one of two ways. You can go to the model menu, right click, uncheck grounded, or you can go to the part, right click, and same thing, ground it. Now it's grounded again, but we want to remove that. So once it's removed, you can move it. Now we want to get this plate oriented so that these two holes align with the two holes in the shaft. To do that, we will use a constraint, but before that I am going to orient this a little bit where I can see the gap on the shaft. So constraint, we will use the insert constraint. Basically what this does is aligns two axes. In the first selection, it is very important. It is very easy. You select either this side or the bottom side of that plate, whichever one you want. It is mostly recommended you pick the one you can see. In this case I can see this one. I don't have to orient it a different way. So I'll select that hole, align it with the top hole of the shaft, and it flipped my plate so that the part that was highlighted on the plate is now touching the plate, the shaft hole. Do the similar. We will first of all we'll apply this. Similarly, we have to align this hole with the second hole on the shaft. However, when we select that, we don't want to select that top surface because it will not constrain. The computer is going to take it as if you have to twist apart in order for that surface to touch this surface. So what you want to do is make sure the bottom part of that plate is highlighted. You can select that one, and it is oriented properly. Now we apply it. It's fully constrained, so we'll exit out of the constraints. So if you want to move the plate, the shaft moves as well. Everything moves together, so it is assembled. Now we want to insert the body of the butterfly valve. To do that, sorry, don't go to constraint, we go to place again. Look, and it should place, you should be in the same file where that folder's at, so you don't have to go anywhere else. And we select the body. Okay. Place one down. Once you place one down, you don't need a second one. You right click, press OK. In order to constrain this, what we want to do is insert this section of the shaft into the body through the counter bore hole that we had created in this part. In order to do that, we simply do an insert constraint again. We want to select this lower diameter of the shaft. Make sure it's highlighted under the extrusion of that shaft, and then we align it to the top of the inner hole. Notice that we apply it, exit out of that. Notice that we cannot move. Notice that if we move the shaft, the body moves as well. However, in this case, we need to make this body so that it's not prone to move. And to do that, again, similar to what we did to the plate where we ungrounded it, now we want to actually ground just the body though. So again, you select that part, right click, and select grounded. Now notice if you try to grab the body, it won't move. However, if you grab the shaft, that will move, just as a rotating motion, because it's already constrained to the insert with the insert constraint. Now we want to bring in our key. Sorry, we're going to bring in the retainer, which is the part that goes aligned with this surface of the body that will create that basically retains that shaft in that position. So we go ahead and press play, place, we bring in the retainer and select open. Place it down at any location. We only need one, so we exit out of that by right clicking and pressing OK. So now I will orient this in a way where I can see all hole features on both the retainer and the body. I will use the constraint insert tool, and in order to fully constrain this, all we have to do is select two of those three patterned holes and align them properly with the body's patterned holes. So to do that, we will go ahead and do the insert constraint. I will pick this top hole on the retainer and the lower hole on the body. Notice that I can pick this top circle or the lower circle. However, I want it to be on the top surface. I'll pick that top one. It aligns it with that hole. Apply. I'm going to exit out just to show you that right now, since we've only done one constraint, this is not fully constrained and it can rotate about that axis. So in order to fully constrain this, notice that this hole aligns with this hole, and that is what we'll focus on right now. So we do a second constraint, insert as well. However, this time we cannot choose this top surface of the retainer because it will not, due to the fact that the bottom or the back side of this of the retainer is already constrained to the surface of that body. You will not be able, by selecting this hole, you will not be able to constrain it. So we select the bottom side of that hole. Or if that's a little confusing, you can always orient your part so that you can see the back side of that. In this case, it is very difficult, or here it is. So we select that part of the hole and we select this top surface diameter of the hole. Now it is fully constrained. It will not move at all, but your shafts can still move, similar to as it was earlier. Now The next thing is we want to insert the woodwork key in this slot of the shaft. Basically what that key does is it makes it so that when inserting the arm, it is not just rotating on the shaft, but it moves the shaft as well. So we go ahead and click place. I don't have my key in this file. Again, it is good practice to have them in the same file. Go to butterfly valve, it is here, open. Just place one down, we don't need any more. Okay, and in order to do this, again, there's going to be two constraints that we do to fully constrain this key. One basically takes my part and places it inside that gap of the shaft. So to do that one, we do an insert, we select this surface of the key and select the edge, the inner edge of the gap or extrusion cut. Notice that if we apply that, the key is aligned with the cut. However, it is rotating about the axis because it is not fully constrained. I will place it somewhere where it is somewhat aligned. What we want to do is basically have it fixed at the most parallel place from this top surface of the key. We want it to be parallel with the shaft. So to do that, we'll select the angle constraint. Again, we want this top surface to be selected. Let's go ahead and exit out of that and select that. This top surface is the one we want parallel, and we're going to have it parallel to one of the planes of the shaft. So go ahead and open up the shaft in the model menu, drop down the origin tab so you can highlight the planes. The plane that we want is the plane that's going to cut the butterfly valve the shaft directly through the middle and is actually parallel to that cut. So in my case, it is the YZ plane. That is the one we're going to use. See how it's cutting directly through half of the length of the shaft. So what we want to do is hit constraint, angle constraint, and we only need two components to make this constraint. So we select on solution, we select the first one, which is directed angle. And what we want to do is we already have, by previously selecting that YZ plane, it already selected that one, and it needs to constrain with this top surface of our shaft. Notice that right now it is not oriented as it is actually on the opposite side of where we want it. We want this curve to be literally inserted into that gap. So in order to do that, notice we have angle here. Right now it's at 0. So basically what we want to do is rotate it a complete 180 degrees. So we simply select 180. Notice now it is exactly where we want it. We apply it, cancel out, everything is good. If we move the key, the shaft moves. That's what we wanted. That was our ultimate goal for this part. Now, lastly, we insert the arm, the last part. So we'll go back to that file. Valve parts, arm, open. I only need one. So I'll exit out once I place that one. Notice again, this arm has the sketches are visible, and it actually has two sketches that are visible. So we'll turn off the visibility on those. So now we want to insert this part into the shaft, and we also want to make sure that this gap of the arm aligns with the key. So first we'll start off by inserting it. So we'll click constraint, insert, and select this outer diameter of the key, and we want to make it insert with the shaft. However, we want it to align as far back as possible. We'll select that first diameter that pops up. That one is the one in the back. We don't want that one. We want this first one. Notice it is there. We apply it. However, if we rotate this around, notice that our gap does not align with the key. Our key is somewhere in this side. So in order, if you want to get to see that, we can simply turn off the disable this part, or the arm, which basically what it does, it's still there. However, it is viewed as transparent. So take off this enable, and you can see the outline and the shadow of that part, but it also gives you the opportunity to view that key. Now, what we want to do in this case is create an angle constraint using the plane that cuts this arm directly in the middle along the horizontal way. So we go to arm, open up the origin. Sorry, I'm gonna have to cancel out of this. Open up the origin, and the one we want is this. In my case, it is the XZ plane. Notice it splits the arm directly through half of it. So we'll select that one. At the same time we're doing this, let's go ahead and open up the origins of the key as well, because we're going to need the one that's the plane that splits it exactly through half of it as well, which is this XY plane. So we go to constraint, angle, solution. We only need two components, and we have the XZ plane from the arm selected already. Now we simply select that XY plane. Notice it is completely aligned and it is 0 degrees. So in this case we're pretty much done. However, I want to show, just in case some of you it actually flipped opposite. Sometimes it'll go 90 degrees and it'll look something like this, where the it is still constrained. However, it's constrained at 90 degrees and your angle is still showing 0. All you do is place 90 degrees and it'll rotate that arm. In my case, I want it at 0. So if you exit it out, you can still change it. Go into the model menu. You notice that constraint angle 2 is there. It's not, I had entered 90 degrees. All I do is double click it and double left click on it, and it'll give me the edit dimension. I change that from 90 to 0 and it goes back to where I need it. Now lastly, let me go ahead and enable this part again. So go back, left click on the model menu, enable, and it's there. Now that I turn it, everything turns: the key, the shaft, the plate, and the arm. So we rotate it a little bit so you can see the inside of that body. We have turned it. One last thing, notice that I did not put screws on the plate or on the retainer. I have decided to do it this way simply because not all computers have the component library, which is used to import those screws. Thank you.